Okay, today we're talking about Chapter 6, Section 5, Angles. So finally, we're out of the whole converting of metric and imperial or US system, and we're gonna get into actual things that I think are a little I don't know, I'd say harder. I guess it's not too much harder, but I mean I feel like we are pretty good at converting units by now. But now this stuff, this is definitely something that many of you probably have not seen since your geometry course, and for some of you non-traditional students, that might have been a long, long time ago. So we're going to have a quick refresher today. So if you've been bored to tears in this class, I'm pretty sure today's going to solve that. I forgot that there's this much stuff. So, and the reason why, I mean, I know I've said this before, but the reason why I like to do this during class is because I like to show that I mean all the information I'm getting is from the textbook. It's information that you yourself can get anytime you want it. So yeah, that's why I teach from textbook. I became an amazing student once I realized, hey, my textbook actually opens. Although I will say this was back when textbooks actually opened. Nowadays we don't have opening textbooks. Put this here. Perfect. Nice. All right. So let's cover everything that we just snipped. Alrighty. So starting off, plane geometry, Plane geometry, is the study of the properties of figures in a plane. Okay, so far so good. The three most basic ideas in plane geometry are point, line, and plane. These terms are considered so fundamental that they are simply called undefined terms. These undefined terms provide the foundation for the study of geometry and the definitions of other geometric figures such as line segment, ray, angle, triangle, polygon. So the idea of an undefined term, um, I mean honestly, I never heard that, at least in this context. I've heard of things used as like axioms, basically things that are so fundamental that I don't know, they're just fundamental. You have to, that there's nothing that builds into them. They are the building blocks. Okay, so if we define a point is represented by a dot. Points are labeled with capital letters. Okay. A line has no beginning or end. Lines are labeled with lowercase letters or by 2 points on the line. That's interesting. That does not look like a lowercase a or a lowercase b, but you know what? We'll let it slide. And a plane is a flat surface such as a tabletop or wall represent portions of planes. Planes are labeled with capital letters. Okay. So next up, we're going to talk about rays and angles. So a ray consists of a point called an endpoint and all the points of the line on one side of that point. So a ray starts somewhere and goes off into wherever. Okay, whereas a line continues in both directions. And an angle consists of two rays with a common endpoint. Okay, so two rays right here with a common endpoint. So let's first look at, or not, I say first, but I probably should have done it when I did talk about these definitions. But if we label point A, we literally just say point A. Okay. If we label a line, we say line L, which is the name of it, line L in this particular case, or we write the 2 points on there with the line symbol above it. A plane, we just say plain P, plain old P. Array is kind of like a line, except instead of the notation right above it being a line going to infinity left and to infinity right, we just simply write the line going to infinity to the right. Now angles are, I wouldn't say little well, they are different. I mean they've all been different, right? So an angle, uh, whatever your endpoint is of those two rays, and in this particular case the endpoint is O, then you would write A OB, the angle AOB. Okay, the vertex is O, so we say AOB. right? More labeling of it. So there are three common ways of labeling angles. So like we saw on the previous example, AOB, right? We could also write just a single angle line here. Uh, this is angle 1 using single numbers such as 1, 2, or 3. Or we could label them with letters. Okay. So um, classifying angle. Oh no, okay, that's there. That doesn't cover anything. Sorry about that. All right, so every angle has a measurement or measure associated with it. So the base unit when measuring angles is 1 degree. All right, symbolized with a 1 and then the little degree symbol there. We know that there are going to be 360 degrees in a circle. Figure 1, which is a protractor here, shows that the measure AOB is 5 degrees. So we write M, the measure, of our angle AOB, right, and again, this is just simply the angle created by the protractor, is equal to 5 degrees. Right? And of course, if we looked at more examples here, looking at a protractor, the measure of AOB now, AOB, is now going to be 50 degrees because we see we're here at 50, right? Well, what about AOC? Well, that's 90 degrees. AOD and AOE is 120 and 180 respectively. So AOD is 120. And AOE, right, that has an angle of 180 degrees. Some more classifications for our angles. Again, these are words you've probably heard before, but you don't use. Well, you might use them. Who knows? You might use acute and right, obviously. But an acute angle is an angle that is less than 90 degrees. A right angle is exactly 90 degrees. An obtuse angle is between 90 and 180 degrees, and then a straight line is, well, it's 180 degrees, right? We see that here with AOE. It's just a straight line. Okay. Um, okay, so check the measure of. Uh, we need figure 3. There it is. Oh no. Oh well. Well, I snipped the uh, solution already, but that's no big deal. I think it's necessary, so we'll put it right here. The important part is that I explain it, right? Okay, so reading from the top here, we see that figure 3, this figure here, is used for examples 1 and 2. Okay, so example 1 reads, check the measure of A being angle 1, B being angle 2, C being angle 3, and D being angle 4. Okay, now, interestingly, that's why. Okay, it's because a protractor, I mean, I wouldn't say a protractor is needed, but a protractor is used for this. Okay, so looking at angle 1 right here, okay, that is, POQ. Okay, well, that's a 45-degree angle, and like I said, it's this is I was gonna skip example 1. Um, I was gonna skip it because a protractor is used for this, and we don't have protractors here. Um, so yeah, sorry about that. I forgot I was gonna skip it. But example 2, well, that's a pretty easy one, right? Example 2, classifying angles by their measure. Um, we can see, at least visually, what an acute, obtuse, and right angles are. So we know that 1 is acute because it's less than 90. Example, angle 2 is a right angle because it's a right angle. And C, POR, so POR, well, that is greater than 45, but less than, I'm sorry, greater than 90, but less than 180, so that would be an obtuse angle. Alrighty, so some more concepts here are complementary and supplementary. So these are two definitions that get confused quite a bit with one another. Okay, so start from the top. Two angles are complementary if the sum of their measure is 90 degrees. All right, and two angles are supplementary if the sum of their measure is 180 degrees. Now, memorize this however you can, whatever mnemonic device you need, but I promise you, well, honestly, I wouldn't say you're going to use this too much, but you will in this course. All right, complementary is 90 degrees, supplementary is 180 degrees, and I'm pretty sure there's a way to really memorize that. You just do. So, example 3, identifying complementary and supplementary angles. So in the figure shown, the line A to D, which is right here, right, using our notation, just a straight line, A to D, is a straight line. Identify all pairs of complementary, supplementary, and straight angles. Okay, so we did talk about straight right here on the second page here. So we did talk about straight, which isn't or shouldn't be too hard of a concept, right? I mean, it's straight. So anyways, so uh, it's wanting us to identify all pairs, and of course I just snipped everything. But looking at this, it looks like right here, angle 1 looks to be 1 and 2 rather. This angle, again, let's see, let's do some drawing on here. If we looked at this angle here and this angle here, okay, angles 1 and 2, well, they seem to add up to be 100 and I'm sorry, they add up to be 90 degrees, which will make this a complementary angle, or the complementary angles rather. Okay. Uh, COD and COA, they're supplementary because, well, if we look at COD and COA, okay, so this angle and this angle, well, they add up to be 180 degrees, so they are supplementary angles. Okay. And of course, we obviously know that AOD is going to be a straight line, straight angle. And we have more supplementaries of BOA. So BOA and BOD, well, they're two right angles, and those two right angles add up to be 180 as well. So we see that, well, they're supplementary. All right, so calculating the measure. So this is something that's we can actually put pen to paper on instead of just looking. Alrighty, so example 4 reads, in the figure shown, we have our line PS is a straight line, and our angle QOP is 30 degrees. So we need to find the angle of QOS. Okay, well, the idea, I guess, the idea of complementary and supplementary angles come into play here because, well, we're given QOP. Okay, well, if QOP is 30 degrees, and from S to P is 180 degrees, or SOP is 80 degrees, then obviously QOS would be 180 minus 30, or 150 degrees. Okay, and B, find the measure of SOP. Well, SOP, I mean, that's the straight line. We just said that, so it's 180 degrees. My degree, I'm making my degrees huge. And then C, uh, are any pairs of angles supplementary? Okay, so what are supplementary angles? Well, supplementary angles, as you recall, are angles that add up to be 180 degrees. Okay, well, right away it looks like we can see here. Let's put a red line here. We know that we can see that QOP and QOS, okay, they are supplementary because, well, we did it in example A, right? 50 degrees plus 30 degrees is 180 degrees. So we could say, yes, the angle QOP and the angle QOS, they're supplementary. Okay, but that's not all. That's not all, is there? It looks like it appears that ROP and ROS are supplementary. So we'd say ROP and ROS. They're also supplementary. Okay, because we just add up to 180 degrees. All right, next we're going to talk about congruent, vertical, and adjacent. So more words I'm sure you've heard before, but it's also words that you haven't used in a while, and that's all right. Um, or if you skipped geometry in high school, which I don't know if you can or not anymore. I don't know. I know that when I was going to school you could, but you had to take like an extra algebra or something like that. Let me just put this right underneath here. Alrighty, so if two angles have the same measure, they're said to be congruent angles. All right, symbolized by, and it's kind of hard to see, but it's an equal sign with a little squiggle on top or a tilde right on top. Okay, so uh, they're said to be congruent angles. Uh, I'm sorry, if they have the same measure, they're said to be congruent. So if we look at our example here, then we see that these are congruent angles. Angle A and angle B, they are congruent because they're both 30 degrees. Okay, so example 5, identify the congruent angles in the figure. So it looks like AOC is the same thing as BOD. Okay, and it appears that AOB is the same thing as COD. These are congruent angles because, well, their angles are the same. More concepts. We have vertical angles. Okay, so what is a vertical angle? Well, vertical angles are congruent. That is, vertical angles have the same measure. Okay, so I don't know. There's no. That's a nice, short, sweet definition, and I don't think it gets any more concise than that. So let's look at an example. So in the given figure, three lines intersect at the point O. Find the measure of each angle. Okay, so we are all intersecting at O here, and we need to find the measure of each angle. Okay, so we know, first of all, QOR is 25. Okay, since we know QOR is 25, we can determine that, well, this angle over here, UOT, is also going to be 25 degrees. Okay, or TOU, it's also going to be 25 degrees. So let's go ahead and mark that. Okay, maybe if we can. Right here, we know that is also going to be 25 degrees. Okay, now it's important to label this so we know that. I can't get a degree going. Okay, you know what? Let's try this instead. Let's put a little arrow here. No, an angle, and we'll put an arrow pointing to it to be 25 degrees. Okay, I couldn't write the degrees too small enough. All right, now it's important. It's important to label that because now from there we know that well we can see that ROS, well that's 90 degrees, and then ROT, well that's going to be 180 minus 25, right, or 155 degrees, because we know that we label that as 55. I'm sorry, 25 degrees. We also know that QOU is also going to be 155 degrees because up here is 25 degrees, and we know that this whole entire line here is 180. So same principle there. And well, that's about it, I guess. So if we're looking at TOU, so that's going to be TOU. Well, luckily we just did that, and we said that was 25 degrees. So that's where we see that. ROS, so ROS, again, I didn't actually mean to talk about all these, but we see that that is indeed 90 degrees as well. POQ, so POQ, POQ. Well, okay, that's something we didn't talk about. All right. Well, we know from P. Let's do a different color. From POR, we know that is a 90-degree angle. Okay. Well, 25 degrees of that 90-degree angle is taken away. So therefore, 90 minus 25 is 65 degrees. So POQ must be 65 degrees. And of course, we see that down there. And then lastly, we have SOT. So SOT, same thing. It is the angle on the opposite side of POQ. So that's also going to be 65 degrees. Okay, the angles opposite each other are the same. All right, next up we have adjacent angle. Pretty sure that we don't go too much farther than parallel and perpendicular, right? Yeah. Okay, so next up we have adjacent angles, and then we're almost done, guys. Adjacent and then parallel and perpendicular, and pretty sure, if anything, parallel and perpendicular are something that you are super duper familiar with, because I know you've had to have used it quite often in your lives. Alrighty, so adjacent angles. So two angles are adjacent if they have a common side. That makes sense. Again, that's another word that we should be familiar with. Adjacency, if they have something in common. Something is adjacent if they have something in common. And in our geometry, they are adjacent angles if they have a common side. So for instance, angle 1 and angle 2 are adjacent angles, right? Because the common side there is at B, right? Angles 2 and 3 are adjacent. This angle and this angle, they're adjacent because they have the C that's in common. So let's use that concept here, down here in example 7. In the figure below, AC, BD are straight lines. Name an angle adjacent to EOD. Okay, so AC, this is AC, this is BD, and we want to name an adjacent angle to EOD. So EOD is this angle here, right? So what would be adjacent to EOD? Well, AOE would be, because they share that E line there. Okay, and well, it says here two other adjacent angles are EOD and well, I'm sorry, to EOD are BOE and COD. So um, EOD, another adjacent angle would be BOE. So BOE, well, it's adjacent because again we're sharing that line E, and then COD is adjacent to it as well because now we're sharing the line OD or COD rather. Okay. All right, and lastly we have parallel and perpendicular lines. Again, I don't feel like much should be said or much has to be said about parallel and perpendicular lines, but obviously we'll definitely talk about them. Oh yeah, I forgot about transversal. Okay, no big deal. I forgot that's one more probably concept that you might have heard, but kind of forgot. Okay, so the last concept, like I said, it's a concept that you're familiar with, parallel and perpendicular lines. So parallel lines, two lines of parallel symbolized by two straight lines there, if they are in the same plane and do not intersect. Okay, so we know that. And perpendicular lines are two lines that do intersect, but they intersect at right angles, and it has to be specifically right angles. All right, so looking back here, these lines are not perpendicular because the intersection of BD is not at a 90-degree angle of AC. Okay. Now a transversal, right? I like that word. A transversal is a line in a plane that intersects two or more lines in that plane at different points. Okay. So we see here in example 7, we can create 8 angles by creating a transversal line. Okay. So Of course, we see some of the eight angles given there. All right, so parallel lines and a transversal. So if two parallel lines are cut by a transversal, then the following two statements are true. Okay, so if we have two parallel lines and we just cut it, corresponding angles are congruent, and alternate interior angles are also congruent. Let me take a step back real fast. Okay. Going back to what we said, oh, this is actually interesting. So, well, no, I'll go according to the book. Never mind. Anyways, these statements are true if you cut a parallel lines with a transversal. All right, the corresponding angles are congruent, which means that they're equal to each other, and alternate interior angles are congruent, so they're equal to one another. So let's look at an example here. Okay. Example 8 reads, in the figure below, lines K and L are parallel, so we see that here. T is the transversal, right? It's the line we're just cutting through there. And we see that the measure of angle 1 here is 50 degrees. Okay? Find the measure of the other 7 angles. So knowing this one angle, we can figure out the other 7 angles. Okay? The reason why is because of vertical angles and congruencies. Okay? So since angle 1 here is 50 degrees, let's see if we can blow this up. All right, I say that because this is one of those problems that show up quite often in your ACT problems, or your GREs. I kind of just want to blow it up to really point this out. Okay, so if this angle is 50 degrees, okay, well then this angle is also 50 degrees, right? And you know what? We'll actually go ahead and I'm trying to say. Okay, it's actually wanting to know the actual angles. Okay, so never mind. I was gonna just try and show the congruencies. But anyways, if angle 1 is 50, then angle 3 is 50. Okay, well, if angle 1 is 50, then angle 2 must be 130, right? Because what we have, the angles 1 and 2 create a horizontal line, which is 180 degrees. Well, if that's the case, then angle 4 must also be 130 degrees. Okay. All right. Well, using our definition before, if we have a transversal here, if two parallel lines are cut by transversal, then we know that corresponding angles are congruent, and the alternate interior angles are congruent. Okay, so we can use that idea and say that, okay, well, angle 5 must also be 50 degrees, and so should angle 7. Right? And again, if they're 50 degrees, then angles 6 and 8 must also be 130 degrees, because again, the horizontal line is what is 180 degrees, or we could just follow along with the first transversal. Okay. So example 8 is probably the funnest you'll have, I think, in this section. All the other stuff is just mindless, kind of computation. But that does conclude today's lecture.